Starting off with problem 1. Where is it? Okay, so starting off with problem 1, we need to know the numbered pairs such that this condition holds. Number of ordered pairs of A and B, uh, and A and B both are positive integers. So as you can see, any number, let's say I have n, I can write it as n minus 1 and plus 1, n minus 2 plus 2, and so on and so forth. So n minus a plus b is equal to n, right? So that is an ordered pair, and I want a is equal to n minus b. So it's just sorry, n minus 2 plus 2, and this whole number will be a. N minus a has to be equal to b. So I want, oh sorry, where is it? So if we just shuffle our equation, n minus a has to be equal to n minus b, and this whole thing becomes our a instead of just this value as given in the question. As you all can see, n minus b, okay, is equal to n minus b. So this is n minus b, and this whole thing becomes a. So I basically need to check how many such a's are there. Then I'll just get how many such b's are there, because for every a there is exactly one b, right? So you can just print n minus, there'll be n minus 1 different a's, right? Because I want this number to be positive, which is greater than 0. So the max value of this will be n minus 1, which will give me 1. So that is why you can print just n minus 1 and get away with it. That's it. So this was the question A. Now coming to B. B, okay, it was a very bad question, very badly written. B, what you had to do was you are given a string. So P, Q, W only consists of P, Q, and W. So P, and let's say I put a mirror here. So what is going to be the mirror image of this string? So Q isn't like this. Q is just this. Sorry, again, my bad. Q is just a 9 or a ulta P, reverse P. W will remain a W. So P, so we have to print the string in reverse order. Replace, you can iterate in reverse order. Replace every P with a Q and every Q with a P. Let the W remain as it is. So that's what I've done. I got the size of the string. I went in reverse order. If it's a W, let it be a W. If it's a P, then print a Q, else print a P. That's it. Because my string consists of P, Q, and W only. So that's it. That was B. Now coming to C. What was C? Let me have a glance. Okay, so there's A, B, C. Okay, so you have two rows, right? This is row 1 and row 2. We can name them. Each row is of size m. So this is of size m and this is of size m. A monkeys can sit here, B monkeys want to sit here, and C can sit anywhere they want. So what is the maximum number of monkeys that you can make sit? So you can use the greedy strategy over here. Obviously, you can just put all A monkeys over here, all B monkeys, because there is no other option for B monkeys, right? You have to go here, right? So all B monkeys will put here, all A monkeys will put here, and so we'll have M minus A seats remaining and M minus B seats remaining, and because B of these monkeys have fat and A of these monkeys have fat, Now this whole, and we have to club it with a C. So what you have to do is, what your equation will be is, you first do M. So it is very much possible that A is greater than M. So M minus A, we just go max of 0 comma M minus A. Why? Because if it goes negative, maximum is just a 0. Sorry, not 0, but maximum of M comma. Yeah. So my answer is minimum of M comma A, whatever I have chosen. Minimum of M comma B, whatever I have chosen. So it is possible that B just fill this whole thing. That is why. And now coming to the C value. So it will be M minus minimum of M comma A plus another M minus minimum of M comma B, and this whole value, sorry, minimum of N comma B, this whole value comma C, the minimum of this whole value comma C. Yes. So we just add these values together and we have our final answer. So why is that so? The max capacity of this whole row 1 is M, and the second max, and I want to seat A people. What if A is greater than M? So that is why this minimum just handles it. Same thing over here, minimum will handle it here. And now for the C, I have removed the number of seats that were occupied by this, number of seats that were occupied by this. So they have been removed in these two equations. And these are the remaining seats, and the same thing with my C I'll have to do. So that's what I'm doing. If you want to see the code, MABC, row 1, row 2. So min of row A plus min of row B, basically this is added to my answer. Now I subtracted row 1 and row 2, so I performed this equation and this equation, right? And answer again, plus equals row 1 plus row 2. I performed this final step and we see out the answer. Any doubt up until here in A, B, and C? Hello? Hello?
No, no doubts.
No doubts. Okay, great. Now coming to D, what does D state? Let me see. Arey yaar. Huh. So coming to D, what does D state? D states that I need to have the mode as AI for all numbers from B1 till BI. Okay. So I am given some array A, which has numbers from 1 to n. We can use this fact to our advantage. Numbers from 1 to n. I have to construct another array B of size n, where let's say I have some AI over here. So AI has to be equal to the mode of all elements from B0 till B of I. And what is the mode? The most frequent element. The most frequent element till here has to be AI. Okay, that's great. So one thing that you can observe is that all the numbers over here are from 1 till n, and over here also I have to use all numbers from 1 to n. Okay, that's great. Now if AI has 1 to n, we can write AI as 1, 2, 3, 4, and 5, right? We can write up until, let's say, dot 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 till n, right? Now if some numbers, it will be removing any one of these numbers and adding this here, and there can be any order. You can have any permutation of these numbers. So if some number repeats, let's say I want to repeat a 3. So I'll remove a 5 and repeat a 3 over here. Now 5 is never a mode in this whole array A. I will never have to use a 5. So what I can do is the frequency of each element I can just put it as 1, right? And now if I have, whenever I get a 1, I'll put a 1. Whenever I get a 2, I'll put a 2. Whenever I get a 3, I'll put a 3. Whenever I want a 4, I'll put a 4. Now I have a 3. So 3 is already a mode, right? Because everyone's frequency is 1. So, and there is one number such that it will never come inside the array and it won't change our mode. So we just put in a 5 over here. Same thing. And we can do this until the end, until n. So basically a number that does not come in our array, that has to be put in as a mode. So it's as simple as that. Now it's just an implementation part. You can maintain sets, queues, or anything. Like, it depends on you. So my implementation, I just found sets easier. So we just put all the numbers in a set. We take input, and if a number exists in my array, we remove it from the set. So basically, if 3 exists, so we remove 3 and all. So only 5 exists in my set. Now I have another set, that is if I have already used this number 3, you can maintain a frequency array, visited array, whatever you want. I'm just maintaining a set. So if it has been used, then use a number from set, remove it, and then remove this number. Now why removing is important? Let's assume there is another number 6 and I also replace that with 3. Now if I put in a 5 over here again, so the mode will be 5, but everyone's frequency I'm just keeping 1, so I'll just put in a 6. That's just the thing. We remove the first element and we mark the current element as visited, and it's C out. That's the core D. Any doubts? Hello.
No doubts.
No doubts. Okay. Anyone else?
No doubts.
Oh, wow. Okay. Now coming to E. E is also quite forward problem. So we are given a range L1 to R1 and another range L2 through R2. Now I have a number y here. I have to select a number x here. And y upon x has to be equal to k raised to some n. N is a non-negative integer, so 0 is also fine. Okay. And so I need to count how many y comma x satisfy my condition. Okay, so not that hard. Why I say, first observation you make, these powers can always be from, and there can be at most 3 of these powers, because my R2 or R1 is up until 1e9, right? So if my base case k is 2, so 2 raised to 30 is greater than 1e9, if I'm not wrong. So at most 30 to 33 powers. Okay. So I can have at most 30 of these different powers to satisfy. Okay, that is our first observation. So we can iterate on each one of them. But now, how to check for some k raised to n value if it is valid? You can write it in a fraction form. It's k raised to n upon 1. And then you can multiply it by x upon x, right? Not x upon x. Let's just call it a upon a. You can multiply it by a divided by a. That's it. And now if you multiply it by a into a, You just need to find all the y's that are there. So k raised to n multiplied by a has to fit in the range L2 to R2. So now I'll also get a range of AL to AR, right? And the second thing is my AL to AR has to fit in L1 to R1. So we just get that AL is equal to max of basically everything that fits into this. So k raised to n divided by uh, let's say sorry, we have L2 divided by k raised to n sealed till R2 divided by k raised to n flowed. Now why is this correct? Why is this range correct? Max of this oh sorry, that's just AL, right? Oh, okay. So max will come out to be comma L1, and same here, min AR will be my min of sorry, R2 upon k raised to n floored, comma R1, and my answer will be AR minus AL plus 1. Basically everything in this range from AL to AR, AL to AR will be my answer. All the values in this range. So how do I do this? I know k raised to n's value, I know L2, L1, but now why is this a seal? Just take an example. K raised to n is 2 and your L2 is 15. So if you do a floor, you will get to know how many 2's are contained in this 15. And if you take a seal, you will get to know how many 2's are there, 15 and just one ahead, like including 15, how many 2's are contained in it. So there's a 16 also, right? uh, so that is why, like 15, so you'll have 16. And same thing for here, take 19 as your R2. So 19 by 2 is exactly 18, or else you would have gotten 20 if you would have taken seal. You don't want to go ahead of 19, so you want to go behind 19, and you want to go ahead of 15. So that is why the seal value and the floor value. So that's it. That's what you had to do. Now if we see, we have our val as one, which is this thing, what we are k raised to n value, and I have initialized my answer to 0. Mul left, mul right. This is what I'm doing a seal. So I'm calculating this part, taking a seal, taking a floor, and then max of L1, min of R1, and yes, we just add that to our answer. Sometimes it might be possible that AR is less than AL, so what you add will just be negative. So that is why I'm just putting a 0 over here, and we increment val. So we just keep on going. Any doubts over here?
Actually, I approached this question with a different approach.
Hmm.
So what I did was y is equal to x into k raised to n.
Y is
So
equal to x times k raised to n.
so now for every k raised to n,
हाँ
I will find the range of y,
हाँ
uh, and the same what you did, like max of that.
हाँ
But I'm getting like wrong answer. I don't know if my formula is wrong or something.
हाँ, it could be wrong. So how are you taking the seal value?
Can like
your code. Okay. Uh, ID. Wait, I'll extract it.
I will be in the leaderboard of DJ. I think I'm your
Wait.
friend.
Uh, info user Sam. अरे यार इतने सारे लोग s dot a yes. I hope it works. Yes, it works. Thank God. Nice. Uh, oh, Rock Lee. Nice. You understood, right? But this thing you understood that for this thing, you need to find a y. Like you can just write it as this thing, a into a, and we are just searching for what thing are we going to multiply al to ar, and a will be the minimum value such that k raised to n is greater than or equal to L2, which is exactly this. So, yes. Uh, okay, which solve? 1, 2, 3.
First,
Okay. Int e is equal to R2 by L1. What? Okay. Okay, you don't need window. R2 by L1. Why?
it like the maximum value that y can take.
Y can go up until R2, right? मतलब big deal.
I also tried, but it didn't. Wrong answer.
अरे भाई. Wow. Okay. You have k and you have your n. Okay. Max of L2 comma p into L1. Oh, this might be overflowing. Hashtag define int long not. Yes, not there. This might be this might lead to overflows for you. Yes. Uh-huh.
Actually, my int is long. I have defined that.
And what are you doing here? No, it's not long. Hashtag define int. Oh, okay. LL long. Okay. Okay. No, still over. Why I'll tell you. L2 P into L1. Okay. Your P can go quite high. Okay. Your P is max capped at 1e9, right? Okay. This makes sense. And what are you doing? L1 max of L2 comma P into L1. Okay. So this multiplied by L1. Okay. Okay. So start of Y. Okay. So you are taking some start of Y. Okay. But then you will have to divide it by also at some
Yes,
point.
I'm dividing. Yeah,
Okay.
I'm dividing it.
Uh, okay.
Basically, seal divide.
This is not seal.
If the remainder is not zero, I'm adding one
हाँ, but this
after
is
that.
not seal. Seal के लिए
Yeah, that is floor.
you can just seal if you want to find A upon B. Seal. Just write A plus B minus 1 upon B float. You have written opposite. You have written A minus B plus 1. Right? Huh. And okay, mx minus mn plus 1 by p. Okay, so you are flooring it and then you are checking. Okay, so you are
Yes.
taking it seal only. Okay, and you are sealing it with P. Uh, this should like, why are you doing P into L1? Can you explain me the logic behind that? What did you see? Like, why
Wow.
multiplied
That
by
y is
L1?
equal to,
Because
I'm basically
these
finding.
L1 and L2 will be very different things then. Because over here, L1 is what I'm multiplying with, and I'm getting, so let's say I have a y upon x by L1. So basically, currently it is 1 only. Okay. So x I just multiply by some L1. Y I'll multiply by that L1 again. But it's not necessary that this comes inside the range. Ha, that is an issue. It's not necessary that this comes inside the range. That is an error. That is one thing I can catch. It's not y multiplied by L1. Okay, so you have x. Okay, so you are getting a y, and what you are doing? Oh, you can't do min L2. L2 is not by y always. L2 won't always be divisible by p. This is your issue, because if L2 is, let's say, some 5, then you will also take into a 5 through, let's say, 10, and a y value that you can take is only 7. You will take 5. uh Sorry, oh, okay, you are, sorry, y value that you can take minimum is a 4. 4 ke baad you can only go to 7, let's assume. So you will take 5, whereas you had to take a 7. Understanding? And
Yeah, yeah,
same error
understood.
will be in mn and mx. And so if you are subtracting, that error can add up or compound, basically, is what I'm saying. So that is possible. This is that is your issue. This it can't be max L2. It has to be the first multiple of P after L2, and this has to be the greatest. This has to be the smallest multiple of P after L2, and this has to be the smallest multiple of P. Sorry, greatest multiple of P before R2, less than equal to.
Yeah,
This should be the error. I can't think of anything. Yes, this should do the work. Yes.
yeah, understood.
Okay,
Thanks.
just try that. And if you don't want that, or you can just try this method. It's just easier to visualize that you are multiplying it by a comma a. You find the range of with what you can multiply al and ar. So it's just that. Now coming to G1. Okay. F I didn't read because I had to go outside, and G1 had more submissions on it, so I decided to read G1. That is the main reasoning. And then instead of G1, like, yeah, I read G2, but then I switched to G1 and stuff. But it's not that hard. G1, any doubts, people? Why isn't this loading? Okay, G1, I'll just explain the question. You are given a cycle, uh, a graph. There may be cycle, uh, there, like, there have to be cycles. So there's graph with n nodes and n edges, and it's directed. So you will form a cycle eventually, because from every node it is connected to some other node and not the node it. So some there will exactly be one directed cycle in this whole graph for G1. Okay. So now you can see there can be some node here and here and here. So what you need to find is that there are some uh, people living on each node, and after every year they and each person has exactly one gift. So one gift, 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 one gift. So every year this one gift is passed on to the next person. And if after and everything happens simultaneously, if after passing a person is left with more than one gift, all other gifts except one gift are discarded. So if I would want to simulate this thing somewhere else, I'll just show you how it will look. So we have this. You can just Control C, Control V, the whole graph here. So this one will just go up. These will have 0, 0. This one will become 2. This one will go away. This one will become a no. This one will remain. This will just go away, and it will become this will also change. This will also change, but this will become a 0 over here. This will also become a 0. Now I'll have added 2 over here. I'll get 2 here and 3 over here. One from here, one from here, one from here. So that's that. So this cycle will keep on continuing, and I need to tell what time, at what point of time will the all the things be stable. Stable. So this state has been achieved before. When will this state be achieved again? That is what I need to say. So, and after a year also, you can just see that uh, it's not 2 3 3 but 1 1 and 1 over here, right? Yes. So one thing that you can see is if I am in a cycle, if I have, let's say, uh, even a like whatever I have, if I'm in a cycle it will always remain 1. And if I am out of a cycle, something like this, so this will become 0, then this will become 0, and this will become 0, something like that, right? And the second thing is all the other nodes are leading to a cycle only in my graph, because there is just one node ahead of each and every node, and all the nodes are leading to a cycle. So that is the first observation. Now I just need to tell the one that was here, how much time does it take to get into the cycle is the question. It will be the length of sync node till the cycle, length of this sync node till the cycle, length of this sync node till the cycle. That is the amount of time this takes to be 0. Till then, all the values in this path will keep on changing. Like this will become 0 in the next turn, and this will become 0 in the next turn, and so on and so forth, until all the nodes that are not part of the cycle become 0. I will have the same state, and once all these become 0, the next state is going to be the same as the previous one, always, right? So that's what you have to do. From the cycle, you need to find the longest length chain of nodes that touches the cycle, and that's it. So you have a DAG, so you can just do DP, you can just apply DP, and whatever the answer plus 1 is your answer. Yeah. So that's it. Now, how do I implement this thing? This I use strongly connected components. Why did I use strongly connected components? Because I had it ready and I just had to copy paste this whole thing. So I just wrote this input, This hole is my template for strongly connected components. This hole also, I just change this one part and this part. That's it. And we outputted it. So how am I doing it? So if I am at a sort of a source node, I put in the value as 2, and the answer is just the max value. And since this is a DAG, the whole cycle is considered as a single node. And since this is a DAG, you can do a topo sort on it. And we have DP next, DP root IT plus 1. So basically, if this is a 2, answer will be 3 and 4 until here. So like 3 chains and one more for the year extra, right? So that's what I'm doing over here, nothing much. And we have to get out the max element. That's it. Any doubts? G1.
Why will there be only one?
Because there are n nodes and n edges. Now if there are n edges, from one edge it will go to exactly one other node, and there is an edge from every node. My bad, I didn't mention that, but there is an edge from every node. So just, so now let's say I made 3 nodes and I have an edge from, so where will I put this? I have to put it here or here. There has to be one cycle exactly. There can't be zero, not less, not more. Exactly one cycle. Understood?
Yeah.
Huh. So basically this is the thing. So from the cycle, you just need to find the longest chain. That is my implementation method. And G2 was also pretty easy. You over here you cannot discard any node. So to send all of these nodes over here, it's basically to the cycle. It's basically the sum of all these nodes. So it's 3 here, it's 2 here, it's 1 here. So it will be the max value of 3 comma 2 comma 1 plus 1. That's what you have to do. Basically you don't discard anything. So if I like, let's assume if I had 100 of these nodes, and these are still feeding it nodes, so, and this has stopped it, it will still keep on increasing. It won't reduce by 100. So it will go to here, it becomes 99 and 1 again feeds here. If both are feeding, then it goes 101. So it increases. So it's basically the sum of this chain and this chain. That is exactly the number of nodes that are here till this path. Nothing else. So that's it. And in the cycle you just need to count the max value. So if I am at a cycle, basically cycle, there will be no outgoing node from the cycle because I'm taking this whole thing as a single node. So if it is a cycle, we put the max value, else we just keep on adding, and we do max value plus 1 in the end. That's it. So that's how you solve this. That's it. That was G2. Any doubts in G1, G2, people? Hello.
No doubts.
Okay. So if you want to implement this thing for the code, it's the same thing as G1, but the small change over here. Once I make the directed acyclic graph, you can learn more about Kosaraju on CP algorithm. Even I learned it from here. You can go to graphs, and where is it? Here. So finding bridges. Oh, yes, strongly connected components. Yes. So this is where Tarians and Kosaraju are taught. And if you want some practice, just go to CSES problem set, and where is this? Solve these graph problems. your implementation will also improve. And yeah, so that's just it. You will apply different kinds of graph algorithms too. So yes, that is a very good way to improve your implementation and graph knowledge, nothing else. Okay, any more doubts and we can conclude? Hello, if it's a no, please tell.
No doubts.
Okay, so people